In chemistry, energy plays a crucial role in the behavior and outcomes of chemical reactions. When chemical reactions occur, they are often accompanied by changes in energy. This energy can either be released into the surroundings or absorbed from them, leading to what are known as exothermic and endothermic reactions. During any chemical reaction, the bonds between atoms in the reactants must first be broken, and then new bonds are formed to create the products. Breaking bonds requires energy, while forming new bonds releases energy. The overall energy change in a reaction depends on the balance between the energy needed to break the bonds in the reactants and the energy released when new bonds are formed in the products. In an exothermic reaction, the energy released by the formation of new bonds in the products is greater than the energy required to break the bonds in the reactants. This excess energy is released into the surroundings, usually in the form of heat. As a result, the temperature of the surroundings increases. Common examples of exothermic reactions include combustion, where fuels like wood or gasoline burn to produce heat, and the reaction of acids with metals, which often releases heat as the metal dissolves. The reason heat is given out in an exothermic reaction is due to the net release of energy. When the energy released during the formation of the product's bonds surpasses the energy absorbed during the breaking of the reactant's bonds, the surplus energy is not needed to sustain the reaction. Consequently, it is emitted as heat, causing the surroundings to warm up. In contrast, an endothermic reaction occurs when the energy required to break the bonds in the reactants exceeds the energy released during the formation of new bonds in the products. To compensate for this energy deficit, the reaction absorbs energy from its surroundings, typically in the form of heat. This absorption of heat leads to a decrease in the temperature of the surroundings. Examples of endothermic reactions include photosynthesis in plants, where energy from sunlight is absorbed to convert carbon dioxide and water into glucose and oxygen, and the process of dissolving certain salts in water, where the solution becomes cooler as the salt absorbs heat during dissolution. The reason heat is taken in during an endothermic reaction lies in the energy balance of the reaction. Because the energy released by forming new bonds in the products is less than the energy required to break the bonds in the reactants, additional energy must be absorbed from the surroundings to ensure the reaction proceeds. This absorbed energy is necessary to overcome the energy barrier, making the reaction feel cold to the touch. In summary, chemical reactions involve the transfer of energy due to the breaking and forming of bonds. Exothermic reactions release energy, causing the surroundings to warm up, while endothermic reactions absorb energy, resulting in a cooling effect. The direction of energy transfer is determined by the difference between the energy needed to break the bonds in the reactants and the energy released when new bonds form in the products.